Hello everyone, I am Nilima Salvi, working as Assistant Professor, Department of Pharmaceutics, Smriti College of Pharmaceutical Education, Indore. In continuation with the pre-formulation studies, today we are going to start with the chemical properties, in which previously we had discussed about the hydrolysis, how the hydrolysis occurs and how we can prevent the hydrolysis. And now today we are going to start with the second chemical property, that is oxidation and reduction. Commonly this is known as redox reaction. And what is the meaning of oxidation and reduction? Oxidation is loss of electron and addition of oxygen into the compound, and vice versa, reduction is a gain of electron. Ultimately, there is in redox reaction, there is transfer of electrons into the reactants. So, how the oxidation and reduction reactions take place into the formulation? Redox reaction could be occur into both solid and liquid formulations, but sometimes they are degradation reaction for the products, or during the oxidation the product could get decomposed during its shelf life. So oxidation and reduction are common pathway for drug degradation in liquid and solid formulation, and commonly they are known as redox reaction. After this oxidation and reduction reaction involves exchange of electron in between the reactants. Then in pharmaceutical dosage form, oxidation mediated by the reaction with atmospheric oxygen. Atmospheric oxygen could mediate the reaction of oxidation, or it could enhance the rancidity into the formulation. Rancidity is none other than oxidation process. So in formulation, during the storage condition, with the interference of the atmospheric oxygen, the substance or the drug product could be rancid or oxidized. After that, oxidative mechanisms are complex and they involve elimination of an electropositive atom and radical or electron. So there could be mechanism which can be involve elimination of electropositive atom or radical or electron. So by the loss of electron, oxidation process could be take place. Oxidation catalyzed by oxygen. If there is oxygen present into the product, then the substance or the final product could be oxidized. So oxidation catalyzed by the oxygen. Then heavy metals, iron, also can catalyze the oxidation reaction, or they increase the rate of reaction of oxidation. After that, the light again could be increase the oxidation reaction or catalyze the reaction, then lead to formation of free radical. All these things, oxygen, heavy metal and light, they lead to formation of free radical, and because of this free radical, again the oxidation process will get catalyzed or increase up. Then aldehyde, alcohol, phenols, alkaloids and unsaturated fat oils are susceptible to oxidation. It means these are the substances or products which could be, or they are more susceptible as compared to the others for the oxidation process. After that, amine, sulfide and phenols are susceptible to electron transfer and they give N oxides. Hydroxylamine, sulfones and sulfoxides. So these are the reactions or the product could be which could be into the oxidation reduction. After that, hydrogen peroxide is widely used for the oxidation of drugs, and some other compounds also could be used for oxidizing the drugs, such as metal ions, oxygen, and radical initiators. Radical initiator, they initiate the formation of free radical into the substance, and the substance ultimately get oxidized. So these things could be used to oxidize the product, and H2O2 hydrogen peroxide is widely used for this purpose. After that, drugs which decompose by oxidation are, or the common drugs which easily get decomposed or degrade by the oxidation, they are arachi's oil, riboflavin, ethyl oleate, vitamin A, vitamin B12, clove oil, morphine, cinnamon oil, prednisolone, epinephrine, and promethazine. So these are the common drugs or widely used drug which easily degrade by the oxidation. After that, oxidation could be occur into the formulation by two ways. First is auto oxidation and second is free radical oxidation. Auto oxidation, it means because of the environmental oxygen, the oxidation process takes place. This is known as auto oxidation. And second is free radical oxidation. It means the free radical could be initiated or start to form into the formulation because of the environmental oxygen, heavy metal, and light. So when free radical will generated into the formulation, they will ultimately lead to the oxidation process into the formulation. So oxidation involves, or oxidation comprises of basically three steps. That is, first one is initiation step, second is propagation step, and third is termination steps. So these three steps are basically occurs into the oxidation reaction. So start with the first initiation step. So in this step, due to some factors such as heat, light, and presence of traces metal such as organic compound, or due to factors such as heat, light, and heavy metal ions, the organic compound, this is an organic compound and it is converted into free radicals. So in this, organic compound is directly converted into the free radical with the help of light, heat, and presence of heavy or traces of metals. Then after this was the initiation step. After that, second step is propagation step. In propagation, what happens? The free radical, this free radical along with the oxygen forms peroxy radical. This is peroxy radical. This free radical contact with the oxygen and gives peroxy radical, which further take hydrogen from another molecule of organic compound RH. Now this will take another hydrogen from the organic compound and again it will form hydroperoxide, which is ROOH hydroperoxide. And now in this reaction a new radical is formed. So this new radical now again this will absorb oxygen from the environment and this reaction again continues. Again I am explaining this reaction, that how the propagation occurs. Initially or in initiation step, in oxidation start, whether this compound or organic compound is directly converted into free radicals with the presence or in presence of light, heat, and traces of metals. So this free radical now this absorbs at radical react with oxygen and convert into peroxy radical. This peroxy radical now again absorb or get free hydrogen from the organic compound or absorb hydrogen from the organic compound, and this now convert into hydroperoxide, and this hydroperoxide again after the formation of hydroperoxide a free radical is or new free radical is formed. Again this free radical will react with the oxygen and this process will continues. This process is known as propagation step, and third one is termination step. So we have to terminate this process to repeat again and again. So how we can terminate this initial propagation step? So in this termination step, certain free radicals are combined to form inactive product. It means this free radical, we will combine this free radical with the some inactive or combine this to form inactive product. So this free radical will give you inactive product which break this chain of propagation reaction. So this was the three basic steps of oxidation degradation. Now the factors which affect the oxidation process are, the most common factor is concentration of oxygen. If oxygen is more, then the oxidation process would be more into the formulation. Second is light and temperature. Light and temperature again catalyze the oxidation reaction. Hydrogen, hydroxyl ion and heavy metals again they affect the oxidation process along with the reduction process. After that, the oxidative degradation of product can be prevented by, how we can prevent the oxidation reaction or degradation mechanism. So first of all we can add antioxidants into the formulation. For example, tocopherol, butylated hydroxyl anisole, butylated hydroxyl toluene. So these are the various antioxidants which can be incorporated or used into the drugs along with the foods. We also can add these antioxidants into the food also. So by adding the antioxidant we can reduce the oxidation reaction. Then second thing is the replacement of oxygen by the nitrogen and carbon dioxide into the head space. So head space is the space of container or blank space of the package container in which oxygen is there. So in head space of the container we can replace the oxygen with the nitrogen or carbon dioxide. So by replacing this oxygen we can prevent the oxidation rate into the formulation. Third mechanism or third approach is avoid contact of drug with heavy metal ions. ड्रग और हेवी मेटल आयंस का कांटेक्ट अगर कम होगा देन फ्री रेडिकल जो है वो कम प्रोड्यूस होंगे, और टू अवॉइड दिस contact in between the drug and heavy metal ion we can store the formulation or drug at the reduced temperature. After that, by adding the reducing agent, we can add reducing agent into the formulation to prevent oxidation. So for this purpose we can add sodium metabisulfite into the formulation as reducing agent or as antioxidant. Then we can add we can go for or find optimum pH to or for the stable product. So we have to determine the optimum pH for a stable formulation. At that pH, if we will store the formulation, then the oxidation would be less as compared to the others. And lastly, we can add chelating agents into the formulation to prevent the oxidation. So this was the oxidation reduction mechanism or chemical property of drug substance till we had completed hydrolysis and oxidation reduction. Thank you.